good afternoon and a warm welcome from our side from MyPV. So Talal and myself, we are sitting right now in the nice surrounding of Upper Austria. Yes, my colleague Talal will hold the webinar. But also Mathieu, our area sales manager, is joining us today. Mathieu takes care about all the French-speaking regions. And I would like to say also thank you to you for participating, for take the time.
So let's start with the introduction part, I would say, where we introduce each other, what will be the topic of today. So, of course, as Andreas already introduced you, likewise, our colleague from Eniris, Bart, will be introducing itself, and then we will be discussing the range of MyPV products and what Eniris as an energy management system has to offer to its clients. So without any overdue, let's go further. So from my side, maybe you can already see my name. My side, I'm handling the technical side. My background is an electrical engineer, and for quite a number of years, I have been working with MyPV. So just like Eniris, MyPV is relatively young company. So we started our journey since 2013, and over the years, we grow up with different products from single phase to three phase to the DC solutions. But nevertheless, we will be discussing them in this webinar for today. So as a company, MyPV, we are an Austrian company based in the Upper Austria province. Those who know lanes or wells, maybe we are very close to that, and we are situated in the Neuzeug area. Here you can see on the left, it's our production facility. It's on the right side, and on the left side it's our, let's say, R&D, our technical sales and support. Everything is based in Austria, so the products are also made in Austria. So these are Austrian products, and you can imagine these are quality made products itself. The building itself is a passive building where we are doing a pilot project itself for heating up the building on a commercial scale. But we can leave this topic for another time. But let's dig deep into the introduction part. So I will leave now to Bart. Bart, maybe you can add some words to your side as well.
No, thank you. Thank you very much, Talal and Andreas. Thank you for the introduction. It's today a collaboration webinar between MyPV and Eniris, and I am Bart Verheke, one of the co-founders of the company. We started in 2018 with our company. First, the focus was on monitoring PV installations, battery systems, but then quickly in 2020, we started developing our own hardware to not do only monitoring, but to also energy management system, and therefore we developed an energy management system called SmartGrid One. And as that started in 2020, we are now serving more than 135,000 residential end customers with monitoring or control applications and more than 8,000 CNI applications. We're headquartered in Ghent, in Belgium, but have also a branch office in the Netherlands. And more recently, we also started a small office in Zurich, in Switzerland, but servicing all over Europe, actually. And with our energy management system, we're quite successful. We won more recently also the Best Innovation Award with that. So pretty proud of that. Talal, I give the word back to you.
Perfect. Thank you, Bart, for introduction. So now let's say what MyPV has to offer to its client as well. So just for let's say to be easy with discussion, you can feel free to drop your messages in the chat. So my colleague Andreas will be there as well to answer those questions, and at the end of the webinar you will get the slides as well. So You do not need to know the technical stuff, I would say, really hard. Rather, you will get those presentation at the end of the webinar. So as a MyPV, what our focus is, these slides try to explain that whenever a PV power comes to your mind, you are thinking, okay, either you can do EV charging or you can do the house loads. What we are seeing as a manufacturer is that yes, with the PV power, you can do other things. What it means is domestic hot water, or you can do electrical space heating by using MyPV solutions. Where our solution fits perfect, there are generally two scenarios. Mostly, yes, our products are focusing the single family homes, so that's a clear thing. Yes, there are commercial applications as well, but let's say the prime focus for MyPV products are the single family home. And further, if we look where they fit perfect, is that yes, here is an energy graph from single family home with 2 adults and 2 kids, and you can see the amount of your electricity consumption and your hot water consumption. Those you can analyze through your energy bills as well. What the clear thing is that you can do domestic hot water with MyPV solutions regardless if it's an old building or it's a new building. Your hot water demand, your domestic hot water demand is roughly the same. The question comes when it's an old building. Yes, in the case of old building, poor insulation, your space heating demand is really, really high. Yes, you can do technically from PV heating, but it will be never enough to do space heating. Compared to that, in new buildings, in passive houses, in modern buildings where your space heating demand is low, yes, you can do both sectors, meaning hot water as well as space heating. You can do both sectors. But yes, in the case of old buildings, the only focus or recommended solution is doing the domestic hot water. What other concept, for example, is yes, for heating, generally you are using external sources for heating. That can be oil, that can be pellets, that can be gas, anything, etc. What we are seeing is that during the day, use as much power from the sun as you can, and yes, during the night, you can use power from the grid as well. With our settings as well, you can use power from the grid as well. The question comes where the energy storage makes sense. For example, yes, there are battery storage which comes first in the mind, that you can store power into your battery storage, but still the price of storage is way higher. The capital cost for battery storage per kilowatt is way higher than we do in your boiler, in your domestic boiler, in your in any 300-liter boiler. You can save more amount of kilowatts compared to battery storage. So it's a more cost-effective way to store your energy. But yes, our system can also be successfully combined with the battery storage systems that we will be discussing in the coming slides, as well as in Eniris will show how things can be integrated together. So the question comes, which products we are focusing today in the webinar. Of course, we have DC products, but today we are focusing the AC products, the ACL2 and the AC Thor. Those are compatible with Eniris system, and yes, that's how we can integrate system together in the case of AC products. Let's continue with the AC products. The reason to have AC products is, there can be a number of reasons, but let's draw down to the simple most is the feed-in tariff. Yes, that's the case already in the Belgium, in Flanders, if I'm correct, that you have already low feed-in tariff. So if you are exporting your surplus power from your PV system, you are sending or you're exporting that power free of cost. The other reason, yes, you can use that power at the house and you can use that for heating purposes. Other reasons, for example, that's the very reason in Netherlands, if I'm correct, that you have a lot of surplus power, a lot of PV power in your grid, and that's is a headache for grid operators. So yes, more power being used at house is highly welcomed, and yes, there can be other reasons. For example, either gas is getting expensive or you need independence from external source of heating. Now we talk about what is the concept of our AC devices. Yes, you have a PV panel, then you have a PV inverter, and from that you are generating AC power that is being used at the house. Once that energy is being used at the house and there comes a time then there's a surplus power, excess power. Either that excess power is being stored in the battery. If there's no battery, then that surplus power is being sent to the grid. I'm here talking about the grid connected PV system. So in grid connected PV system, your surplus power is being exported to the grid. What we exactly do is we get that information about the surplus power and divert that surplus power for heating application. So in that case, we have number of products, or just draw down to 2 products which are using that surplus power for heating application. So the first product is the AC ELVA 2 from the abbreviation AC, alternating current, and ELVA is a German abbreviation for electric water heater, and 2, it is because this is the second generation. The earlier generation, maybe few guys know that there was a green color and it didn't have the Wi-Fi and lower power capacity, but over the experience which we have gone through is that we are able to maximize power. That's with higher capacity, 3.5 kilowatt. Plus we have also added the touch display, which we know from our experience that it has been highly helpful in terms of commissioning of the device and later on the settings that has been needed to do that. Plus in terms of communication, we have brought it into, for example, there's a Wi-Fi connection, there's a LAN connection, and plus RTU connection. So there are different possibilities in terms of communication. So here comes Eniris in the picture. How it comes, let's explain, or let's draw down into this schematic. Here, as a general application, we have a PV system, we have a PV inverter, and what's happening is that somebody's turning loads in the house, lights are being turned on, off, so everything is in the feeding point, the power is continuously fluctuating. There's a change in the balance. And what we get as a information is, because Eniris is, let's say, a management system which has the information about the excess power, about the surplus power, and we read exactly that surplus power from the Eniris, because Eniris is integrating everything together from the inverter. It's getting the information, and that information is further passed on to our device as AC ELVA 2. One thing which I want to highlight is that what we are doing is we are doing a linear power control. What I already said is that the power at the feed-in point is continuously changing. 1 second it's 100 watt, the next it can be 1000 watt, the next it can be 0 surplus power. So we are reading that surplus power 1 time per second. So you can imagine that's really exact, precise, and speedily, and we get that information. And once we get that information, we are reacting to that information also very swiftly. So 1 second it can be 1000 watt, the next second it can be 100 watt. So we use every surplus watt for heating up the water. So every excess watt is being used to heat up the water. There's no power wasted in terms of sending to the grid. So that generates more savings in a long term. So discussing further with the ACL2, we call it all-in-one solution. The reason to say that is because you can see there's a head unit with it, and then there's a heating element with it. So in terms of installation, this is pretty straightforward because you just need to source a buffer boiler or a tank which has a 1.5 inch thread. So that's a pretty common European standard to have a thread size of 1.5 inch and then a minimum diameter which can have the heating element. So you need to take care of these two parameters in terms of sourcing the ACL2. It's regardless of the brand of the boiler. It's just these 2 points you need to consider in terms of installation. As already told you that there are a number of communications possible through with ACL2, especially if we are discussing how it communicates with Eniris. It's over Modbus TCP or standard Ethernet connection. So that's how it can communicate, and we can discuss further on it. But of course, Bart will discuss more intensively how this works beyond that. So some of the technical stuff, I think I already mentioned that, but just to highlight again that we are doing really a step less or variable power control from 0 to 3.5 kilowatt. Plus, we are not using any tri-X or thyristors because those can be those can generate harmonics, those can generate problem for the grid operator. So we are running our devices on PWM sine wave. So that's a sign of quality itself. So that's some thoughts on from my side. But yeah, you will get these slides and all the data sheets, the operation manuals, the installations are there for ACL2. Some interesting case study from ACL2 from Netherlands itself as well. So it's a user who really had a big PV system, 153 kilowatt peak system, and he had a boiler of a 200 liters. So the interesting point is that he's exporting a lot of surplus power into the grid, and for that he needed to pay extra fees as well. So what he has been able to done is, first he fills up his battery storage, so battery storage is full, and after that the boiler is being heated up to 80 degrees, as you can see in the schema in the widget itself, that you can see visualize the temperature of the boiler as well. Yeah, continue further. A little emphasis on the battery storage. If we talk about PV self-consumption, yes, normally you have a PV system of 6 kilowatt and you have a PV self-consumption of roughly 25%. Yes, you can achieve higher PV self-consumption with the battery, but again, that comes at a higher cost. Most cost alternative which we can suggest is that with our system you can achieve higher PV self-consumption up to 75%, but nevertheless you can combine both systems together with MyPV and achieve higher PV self-consumption. How it works with the battery storage, normally it's recommended to do battery storage first, because once you put power into the battery you can get back that power, but once you put power in your boiler it's hard to take back. So in a normal day chart curve, once the battery is full, then the power starts diverting to thermal storage. So that's how it responds to the system as well. Then we have our planning tool as well, how the system or configuration looks like. You can use it for free of cost for your technical team, for your sales discussion. What you can put here is how big is your PV system, your feed-in tariff, your electricity price, how big is your boiler, gas price, how many people are in the house. There are already different locations across Europe, and at the end you can see how much savings you can make it, what will be your self-consumption, what will be your independence ratio as well. So you can get this report free of cost. There's nothing specific need, just play with this tool for your planning and as well. Then we have the AC-Tor 9S. So generally, let's say the term is solar power diverter. The principle is the same as ACLWA2, which I showed you earlier. So let's go some slides back. So here, imagine if you cut the heating element, then only the electronic head unit remains. So this electronic head unit which remains itself is called AC-Tor. So that's what you call AC-Tor. We have two variants in it. On the left you can see there's a single phase variant, then on the right it's a three-phase variant for, let's say, bigger applications, higher applications. So the left, the AC-Tor, you can see both are in the same cases, but on the bottom side you can see there are different outputs. On the left it's a single phase 3 kilowatt unit which can do a linear power up to 3 kilowatt. Then on the right, yes, it's a three-phase unit. You can do a linear power control from 0 to 9 kilowatt. Each output can be 3 kilowatt, and you can always prioritize the output as well. So that's further possibilities in terms of terminal boxing. You do not need to open anything. It's just everything is plug and ready. The Ethernet connection is there. The temperature sensor is also supplied with the AC-Tor, so those are supplied together as well. In terms of operation, yes, mostly it's hot water or domestic hot water, but yes, there are other possibilities depending upon your project, because every project is particular, and you can ask us always which kind of mode do we need to adopt. For example, you can combine it with space heating in mode 5. In mode 7 you can combine it with water circulation pump, so that is also possible to do in terms of applications. Again, a short schematic in terms of AC-Tor. As I said, in terms of ACLWA2, we call it all in one unit because heating element and the power manager was together, but that was limited just to domestic hot water. But in terms of application, AC-Tor is more flexible. What it means is that you can connect AC-Tor with existing immersion heater, existing heating element. You can combine it with the boiler which already have a heating element, or you can do electrical space heating, which I will elaborate in the next slide, but let's talk about this one as well. So you have again standard PV system with the PV inverter, and as a EMS system, smart home manager, I would say Eniris is getting that information, and we are getting that information from Eniris, and we are reacting to that very, very quickly. So on the screen you can see different temperatures on the boiler as well, and it's doing a linear power control, in this case up to 1800 watts. So you can connect 9 kilowatt three-phase load with AC Tor 9S, or in case of AC Tor, you can just connect a load up to 3 kilowatt. A different example in terms of mode 5. Here again, I would highlight this is possible for modern homes, for passive house, where your space heating demand is really low. And here you can see the one output is going to your boiler in the buffer tank or in any cylinder. Second output is going to is going to your electric space heating, the underfloor electric space heating. The third output is going to your infrared panel. So you can combine any resistive load with the AC Tor, and you can prioritize your temperature according to that. For example, room temperature is always different, and the boiler temperature is always on another setting. In terms of communication, yes, it's more or less the same as ACLWA 2, and with Eniris, again, it's the Modbus TCP for the communication. Some interesting case study from Belgium this time. So this is an AC Tor. It's being in operation since 2020, so it's already for quite long time with our first adopter in the market. And here the system works with the pellet heating as well. So just an example, yes, the house itself is PV powered. During, let's say, the winter time, it's pellet based heating, and during, let's say, from spring till autumn, AC Tor is able to heat up the water to meet up the hot water demand. So the user can completely turn off the pellets, and he can generate more savings on the pellet side as well. Yes, in the winter it runs in a combination with pellet heating, but just to give you a feeling that there are different options to integrate the system as well. Some technical stuff which I already mentioned, so you will get the slides at the end. In terms of power, again, I would say AC Tor 9S is up to 9 kilowatts. One thing which is important is that AC Tor 9S needs a neutral connections. There are cases which I have come across in Belgium especially, that you have a three-phase grid, it's a delta grid, and you do not have a neutral there. So sorry guys, in that case you cannot use our three-phase solution. In that case you can only use the single phase solution, the AC Tor or the ACLWA 2. We have reference cases where the users have done single phase installations, because we are reading the sum of excess power. So we get full power, we get the information as a total, and we react to that in a single phase device. Yeah, we have our on our homepage we have an instruction manual, so how we can integrate our system together with the Eniris energy management system. So it's a step-by-step approach where of course there should be a router connection, a network connection, in which our device, the MyPV device, and as well as Eniris system are both together in this system, and through Modbus TCP we are communicating with them. But I will leave that part to Bart. Bart, I would say enough from my side. I will leave it to you. So please, I think it will be definitely interesting to get to know how different parts from PV system can be integrated together. So over to you.
Yeah, thank you, Talo. Well, maybe then let's dive a little deeper into an energy management system and what is like the purpose of an energy management system altogether with the solutions of MyPV. We started off
But I think your mic and camera is off. Yeah.
All right. I hope
You're back.
this is stable. I needed to connect and reconnect the whole time. Okay,
Okay.
start again. Uh, all right. Once again, back. So what are the criteria for developing for us like an energy management system? Why did we consider this? But first of all, for a system like that of MyPV, it is actually great to connect it as well to an energy market. Let's pick, for example, the day-ahead market, the apex spot market. Connecting that to such an energy market is a relevant topic, and that's a topic for an energy management system. Second is an energy management system can also help you with managing multiple brands of PV installations, existing boilers, charging stations. Um, I will later disclose how many integrations we have done, but in today's market, European market, you encounter a lot of different brands, and they all need to work together in order to have an efficient system. And the third thing why an energy management system is relevant is because no one can foresee how the future will evolve, what energy techniques will be relevant in the next years. With an energy management system, you have the functionality of working with like multiple drivers. If we update the system, you get these new drivers for new interesting techniques. So we developed an energy management system. The name of the system is Market One, and we have this available for like the residential market, commercial, industrial market, and even on utility scale, we use our solution. It comes, of course, in different form factors. So we have for like the CNI market, but also residential market, this device, which has lots of inputs and outputs. Think about like relay functionality. Think about RS485 functionality available from one device. We have then also a lightweight version, which then just can connect over Modbus TCP with the devices of MyPV or other devices. And we have even, besides the hardware solution, a cloud-based solution. So why do people choose SmartGrid One as an energy management system together with the modules of MyPV? Well, one of the reasons is the compatibility. We support more than 250 devices, types of devices actually, like ranging from MyPV to, let's say, Afore, SIA, SMA. These are all well-known battery systems, PV installations. You can find more information on our compatibility by clicking on this link. So yeah, I can also showcase this later, our docs. So why to choose SmartGrid One? As I mentioned, you don't have to consider actually working only in the residential sector with our solution. You can actually work in all of these sectors. So there are no real constraints in this. And then in terms of energy markets, these are like some company names, some energy providers, more especially for like the Netherlands and Belgium. But all over Europe, we support multiple energy companies, aggregators, which give us access to energy markets such as the imbalance market, the ancillary market. But for like an application such as that of MyPV, it is fair to say that the day-ahead market is already an interesting market, right? you don't encounter actually these applications on the imbalance market or the ancillary market. It would be the requirement would be that the volumes are much larger actually. Our energy management system doesn't work from the cloud, so all the computational decisions, all the computations are done locally, and that makes it also an energy management system which can work, let's say, for a few hours without internet. The disadvantage is, of course, you don't get then any weather forecast anymore, but we can operate in fallback in a worst case scenario without the internet and still are able to manage your residential installation or CNI installation. What are like the functionalities of our system? What are the optimization modes? Well, we can first of all think about peak shaving, right? Where if you have like the desire to work with a heating system, which is equipped with MyPV, you can think about reducing the load of that device for the purpose of peak shaving. So making sure that your grid and the constraints of your grid export and grid import are maintained. And if you have a battery system, we can even control that battery system in order to support those grid limits. We can do curtailment. So if, for example, the MyPV solution is making use of the surplus, the energy surplus, but you still see the possibility of feeding back into the grid, well, then in that worst case scenario, we will limit the PV production to maintain self-consumption and to make sure that your MyPV solution can still work without just shutting off the whole PV installation. Self-consumption optimization is, of course, also an interesting optimization mode in which we just not consider the energy market, but consider getting the most out of the energy surplus or the PV production as mentioning an asset. Load balancing is also an application. Think about like charging stations, which we can control. And then the zero export functionality I already mentioned. Yeah, we do white label our EMS system. You might encounter that system under different brands, as well as the app. We'll showcase you right away then the app. Let's maybe then share my screen. I will first of all show you as well how to integrate with the MyPV system. And therefore I have this small demo. So this is the backend of our energy management system, our SmartGrid1 system. And to connect with the MyPV installation device, you need to pick the heat pump, boiler, and HVAC section. So that's actually what I will do. First, I need to set up my VPN, which I turned off for the webinar. Yeah, there we are. So in this section, you actually can see the logo of MyPV. So when I click on MyPV, you can see that the default communication interface is Modbus TCP. So we communicate over Modbus TCP instead of RS485. That makes it a really easy interface for us, since you don't have problems with installers switching up two wires. It is just all on the network of the customer. And when selecting next, you can actually then pick the specific device of MyPV. And it is actually as simple as that. Now you can click on next and it will scan in the network for the selected device type. So when we have discovered that device, it will appear in the list of known devices. As you can see with the MyPV boiler, You can actually also say, I would like to, for example, connect with my PV installation. There is no limit actually in the number of PV installations, especially if it's not on RS485. So on Modbus TCP, no real limit. On Modbus RS485, the Modbus RS485 bus has an actually a capacity limit of, let's say, 12 till 20 devices. But you can then, it's the same principle actually. You can then connect with like a PV installation. Let's say I would like to connect with a GUI system. Then you can see as well, we support the Modbus TCP interface. Would it be, and then I need to deliberately pick something like DEA. It's again Modbus TCP, but maybe autark. Well, in lots of cases, you would also see an RS485 interface. So we offer both as an interface. You can even go with, let's say, a battery system. So in this list, a long list of battery systems which we support, energy meters, as well. Typically, if we talk about Belgium, you can go with Fluvius. So Fluvius is for your digital meter, and then we make use of the P1 interface. That's the interface which is the uh, public interface for your smart meter, which provides us in real-time measurements. In the Netherlands, there is no grid operator Fluvius, but there you have to pick then the specific brand name of your energy meter. Let's say you encounter Iskra a lot, Landis+Gyr, Kaifa, and by selecting one of them, you can again select the P1 interface. So it's a really easy interface. You have this library of drivers. MyPV is well supported in this list. And by clicking on these devices, you build up your setup, um, which consists then of a digital meter PV installation and your MyPV device. If we go then to the settings page, you can set the limits of your installation. This is our prio number one always. We safeguard the limits of your installation. If we talk about the grid import limits, the grid export limits, you can enter them over here. Let's say if you would enter over here grid export 0, then we have like this limit. We cannot feed back into the grid anymore. And then it makes sense actually to put, for example, um, to actually make use of your MyPV installation and make sure that all that energy from the PV installation, that surplus, is feedback into your MyPV installation. So yeah, since this is under the category of hot water boilers, you have to pick from the list the self-consumption optimization mode. When you would click on the cost optimization mode for your MyPV installation, it would look at the day-ahead market, so the Apex spot day-ahead market, or it could be also the Nord Pool market if we're talking about like the Nordics or the Baltics region. And it will then look at charging the MyPV device at the cheapest price. All right, so this is then your technical setup. What do you see from the front end side, from the app side? Well, from the app side, you will see something like this. You will see how the grid is behaving. I can even click through and see like historical data of the grid. I can see how my PV installation is performing. I can see also in the same overview my PV device. So for my hot water boiler, I can as well check the historical behavior. When did we charge, or when did we charge the device? And I can see the self-consumption of my household. If I would have a battery system or a charging station, I have also that information in one overview. Okay, was the small demo. So now I will switch back to the presentation. So as you saw, we have like this web portal. We have the app, and we have the device as solutions we offer. I also specified already that the device, the SmartGate 1 Pro version, is equipped with the Modbus RS485. This is not required for the MyPV devices, but is required for for example, PV installations, battery installations, charging stations. The Modbus TCP interface is the default interface for your MyPV installation. Some of our Pro versions are equipped with relays to switch on and off, let's say the SmartGrid Ready devices. Then we have also the light version of our EMS, which is, well, it's not the same device. It's like instead of the metal box you get from us, you have like a plastic version. RS485 is an option rather than it's already part of the system. But it has also the Modbus TCP interface. It has no DIN rail mounting. And the typical setup, as I already described in the demo, seems something like this, where we connect with the grid through the P1 interface of a smart meter. You can also use your own energy meter. We can control battery systems, charging stations, solar inverters, and then the MyPV module, or directly via the SG Ready interface. And the energy markets on which we're active is the day-ahead market, but can be also more lucrative markets such as the imbalance market, FCR, EFRR, MFRR. But these markets, the last markets I mentioned, are not the markets on which a hot water boiler is that relevant. Okay, we already touched upon the live demo and the combination with MyPV. In this overview, you can again see our compatibility with the MyPV devices. So we support the whole range, but not through RS485. That's not a really like a difficulty, right? That's not a problem, to be honest. Okay, then Talal, I give back the word to you.
Yeah, indeed interesting, I would say. So yeah, at the end we are getting somewhere towards at the end. But yeah, just I would say we have already sales channel, I think, in terms of mutual. We already have a sales network in Belgium, in Netherlands, and we are always also expanding our area of influence, let's say that. But yeah, we are always open in terms of cooperation as well. But on your homepage, you can always see where you can purchase our device as well, or you can just directly ask us on the email how this process works as well. In terms of our support, yes, it's valid for every level. It is available, but especially for installers, we go one step ahead. Yes, in terms of issue, we need a detail of what's problem with the device, what's wrong with it, and our support department will get back to you. Yeah, I would say have a nice evening, and from my side, bye bye. Maybe last words from your side, Bart.
Yeah, the same. Thank you very much as well, everyone, for joining this webinar, and a special thank as for MyPV as well, of course. And have all a great evening.
Okay, cheers, everybody.
Yeah.
Bye.
Bye.